Hello everyone. Today let's solve the problem almost prime. So this was asked on Codeforces beta round 26, right? So just give me a second. Here the first question. So this was asked in Codeforces beta round 26, right? So here you can just go through the question. It's very easy. Let me summarize this question for you so that it will be easier for us to solve the problem, right? So we have been given integer n. So this is nothing but the integer n input, right? So we have been given an integer n. We have to find how many numbers from 1 to n, this is completely inclusive, have exactly two distinct prime divisors. So this should, we have to find whether how many numbers from 1 to n have exactly two distinct prime divisors, right? So these numbers are called almost prime. These numbers are called as almost primes, right? So here uh, we have been given, I hope the question part is completely clear, right? So we just have to find the numbers from 1 to n. We have been given n and we have to find the numbers from 1 to n which have exactly two distinct prime divisors, and the numbers are called as almost primes, right? So for example, they have given here n equals 10, and here uh, numbers like 6 and 10 are almost primes because we have 2 into 3, nothing but the 6 for this one, and 2 into 5, nothing but 10. They are almost primes, right? They are almost primes. So output equals 10. Output equals 2 here in this case, right? So output equals 2. So for n equals 21 here, for n equals 21, the almost primes we can consider for this one is 6, 10, and also 14, 15, 21, 22, 26, 23. Total we have output 8. So this one you can just check. You can just check in the same way as we did for the output 10. As we did for the output 10. Again, I'm telling the question is how many numbers from 1 to n have exactly two distinct prime divisors. So we have to go with the prime divisors, not the prime numbers, right? So how many numbers from 1 to n have exactly two distinct prime divisors, not the prime numbers between 1 to 10. Don't get confused here, right? So given an integer n, find how many numbers from 1 to n have exactly two distinct prime divisors. These numbers are called almost primes, right? So for n equals 10, numbers would be 6 and 10. 6 and 10. So 6 because 2 into 3, and 10 because 2 into 5, right? So these are almost primes. So same goes with n equals 21. You can just calculate in the same way. I mean, you can just try it out in the same way that we tried for 10, right? It would be 6, 10, 14, 15, 21, 22, 26, and 33. So yeah, 33. So we have to this one, what do we call, display the output 8 in this case. We have to display the output 8 in this case, right? I hope the question part is completely clear. I hope the question part is completely clear. So now this is, and this is the output, right? So I hope the input part, input output part is completely clear as well. As we are done with the question, let's do one thing. Let's discuss the approach. Let's discuss the approach followed by the complexities, and then let's write the code, right? So first let's discuss the approach. Here, I have considered the same first example that they have given in the this one. What do we call? Example 1, right? So n equals 10. They have given the output that we need to get here as 2. Nothing but 1 is 6, which is basically 2 into 3. We know this one. 1 is 10, which is basically 2 into 5, right? So these are the prime divisors or almost primes. They have called it almost primes in the this one. What do we call? Question, right? So these are the two numbers which are almost primes. So the output that we need to get here is 2, right? So here we will be going with a custom linked list, right? So we will be going with a custom linked list. We have not used custom linked list. So for this particular problem, we'll be making use of the data structure linked list basically. And custom linked list is nothing but we'll be going with a node. We'll be defining the node and we'll be going with the custom linked list. So the problem with will be little bit lengthier, but we will understand the linked list better, right? When we go with the custom things, we understand the linked list topic even better. So for this particular problem, we'll be going with the custom linked list. Basically, to solve the problem, we'll be making use of the linked list data structure, right? So this is fine. So next, let's move on with the step-by-step explanation. We have to generate all the primes up to n. First, n we have been given 10. The same example we are considering. First, let's generate all the prime numbers up to 10. So up to 10, what are the prime numbers we have? 2, 3, 5, and 7. 2, 3, 5 and 7. These are the prime numbers, right? Which is divisible by itself and 1. So here the numbers from 1 to 10 which are prime are basically 2, 3, 5 and 7, right? So for each number I to 1 to 10, we have to count how many distinct primes divide it, right? How many distinct primes divide it. Let's see this one further basically. So we have the number 6 basically. We have the two prime numbers here. One is 2 and another one is 3. So we have to consider the numbers, this one basically according to this sentence. For each number I to 1 to 10, we have to count how many distinct primes divide it. How many distinct primes divide it. Here in this case, we have got 6, 2 into 3, nothing but 2 primes, 2 prime numbers we have got. So this is almost prime. 10 we have got this one, 2 into 5, both are prime numbers here. We are considering this one, this is also almost prime. We can consider 4 and 8 as well. 2 after 2 the even numbers we are left with us 4, 8. So 5 is prime and 7 is also prime, right? So 9 is odd. So here in this case, we can consider 4 and 8, but 4, it will be 2 into 2. It will be 2 into 2. This is one, it consists of only one distinct prime here. Only two, right? So we need two distinct prime numbers here. Means two different numbers, right? So two different prime numbers. So this consists of only two. So this doesn't work in this case. We have to have two distinct prime numbers. So here we got 2 and 5, which are two distinct or two different numbers. Here we got two distinct numbers, nothing but 2 and 3. They are two distinct prime numbers, right? So this one, let's come to the final part here, 8. This will be 2 into 2 into 2, 8. Here again, we have got only one distinct number. We have got only one distinct prime, basically. One distinct prime, nothing but we have got only two. This also doesn't work, right? So we have to have two distinct prime numbers, right? So this doesn't work as well, right? Only these two work, nothing but 6 and 10. 6 and 10 here, 6 and 10 work. So we will count the number of almost primes here. In this case, the number of primes, so just give me a second here, 1 second. So yeah, we have got two numbers which are almost prime, right? So we will return that count. We will return the count of almost primes and return 2. So the output that we got here is 2, which is equivalent to the output that they have given for the example 1 in the question. So our approach works absolutely correct in this case. Our approach works absolutely correct in this case, right? So as we are done with the approach, or as we are completely familiar with the approach, let's discuss the complexities very quickly. So the time complexity for the code that we'll be writing in the future would be because of n into square root of n. N into square root of n, because we are iterating from, or we will be iterating from 1 to n. We will be iterating from 1 to n because n we have been given 10. We have to check for all the numbers. First, we have to check what are the numbers that are prime the between 10. Basically, we went with 2, 3, 5, 7, right? These were the prime numbers between 1 to 10. And then we have to take the numbers. So this one, we have for each number I to 1 to 10, we have to count how many distinct primes divide it, right? So this one we have to do. For that one, basically, we iterate from 1 to n, and for each number we check divisibility by primes up to n, which takes square root of n times, right? So basically it would have been big O of n. As this one takes up to square root of n times, it would be big O of n into square root of n, big O of n into square root of n, right? So overall time complexity would be big O of n into square root of n. So what would be the time complexity here, space complexity here? Space complexity would be big O of n, because in the worst case we might store all the prime numbers in the custom linked list, right? So we might store all the prime numbers in the this one custom linked list, right? So the overall time complexity and the space complexity for the code that we'll be writing in the future would be big of n into square root of n and big O of n, right? I hope the complexities part is completely clear. I hope the complexities part is completely clear. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. let's start writing the code. Before writing the code, again I'm telling, we will be going with a custom linked list for this particular question. The data structure will be making use of would be linked list, and we would be going with a custom linked list. Means will be initially we'll go with the node and we'll be making use of the custom linked list, and then we'll be going with the logical part basically, right? So this will be the structure of the code. Just keep this in mind, right? So now we are completely familiar with the complexities and the approach. We are good to write the code. Let's start writing the code. Let's start writing the code now. I'll just come to this one, compiler. So we will be going with the fast input and output. So let me do one thing. Let's import this one. What do we call input output? I'll just go with java.io.start. So this is fine. So let me import. We'll be making use of the utilities as well, right? So let me go with java.util.star. This is fine. So after importing these two things, let's move on with the class. So I'll just go with the public class main here. Within this public static, this one, I'll just give main here. Just give me a second. Yeah, this is fine. So here within this class, so what we'll be doing within the main class basically. So let's do one thing. Before this, let me do one thing. Let's initialize this one, or let's go with the node method. So let's go with the node class to build the custom linked list for storing primes. We have to store all the primes, right? So we have first step accordingly with the approach was to store the primes between 1 to n, right? So let's create the node class to build the custom linked list for storing primes. So this would be static class node. So within this class, let me go with int value. So let me initialize the value here, int value. So this is fine, and let's go with the reference to the next node as well. So this will be node next. We are just going with the reference to the next node. So let me quickly write here, node of int v, node of int v. So let's initialize the value. So let's go with the initialization. This is just but the initialization part. So this will be this dot next. Let's initialize the next pointer to null. Next pointer to null initially. So this is fine. So next step after this would be we'll be making use of the custom linked list class to store the prime numbers. So we know that I said this during the approach as well. We'll be going with the custom linked list. First we'll be creating the node class, then we'll be going with the this one, custom linked list class, right? So here we'll be creating the custom linked list class to store the prime numbers. So I'll just go with static class linked list. So this is fine. Within this class, what we'll do first, let me go with the node head. So this is fine. So the next step is I'll just go with method add here. So let me pass this one, the parameter value. So within this method, so let me do one thing. Let's create the new node first. Let's create the new node. So we need new node, right? So I'll just go with the new node. New. This will be node. The variable name is new node, but we are going with a node. We are just creating a new node here. Let's pass the value. We have to pass the value at any cost, right? So if the list is empty, so we have to go with the condition if head equals null, then we have, if the list is empty, then we have to assign the head to new node, right? So new value, right? This one here, head equals new node. So this is fine, and we don't have to return anything, as we are just assigning the head to new node, yeah, right? So we don't have to return anything. So I'll just give return here. So the next step here would be so I'll just consider the temp variable here, temp variable, and assign this one to head. After assigning the temp variable to head, we have to traverse to the end and append the node, right? To traverse to the end, I'll just make use of the while condition here. This will be temp dot next not equal to null, then temp equals temp dot next. This is fine. So the next step would be we have to append the node. To append the node, it would be temp dot next equals new node, right? So this is fine, I think. Now, yeah, we have successfully appended the node at the last line, right? So now we have to count the this one, right? So we have to count the uh, primes. We have to count all the nodes which consists of the prime numbers, which is a prime number basically, right? So we have to count all the nodes which are primes basically. So I'll just go with int count here, so within this one, what shall we do? Let me initialize the count cnt to 0, and let me go with temp equals head. This is fine. And let me go with the while condition here, temp not equal to null. This is fine. So we are just counting all the nodes, nothing but primes. We are counting all the nodes which are basically primes. So here, if it is, then we are incrementing the count. If the node consists of the prime value, then we are incrementing the count, and we are assigning the temp to temp dot next. We have to see count other numbers as well, right? We have to count all the nodes here, right? That consists of the prime number basically. This is fine. Then finally we have to return the count. Then we have to return the count. So we are done with this part. So now what we need to do, we need to check if the number is prime or not. We need to check whether the number is prime or not. So we are done with this part. Let's go with the method is prime. So I'll just go with static here. Let's go with boolean is prime. So within this one, I'll just give int x. This is fine. So within this method, what shall I do? If x less than 2, then what we will do? If x less than 2, then we will return false. Will return false. If x less than 2, then we'll return false. We will check the divisibility up to the square root. We have to check the divisibility up to the square root, right? So here in this case, let's go with the this one. What do we call for loop? We will check from 2 prime number. If you remember this one, the code for the checking prime numbers, right? So we'll go with the 2, right, for the prime. So I'll just go with I into I less than or equal to x basically. So here I plus plus, as x is the parameter, right? We have number basically, right? So I equals to I into I less than x, less than or equal to x I plus plus. We are just checking the divisibility up to the square root x here. So to check the prime numbers, we have to go with the x module I. If it modulo I, if it is equal to 0, if it is equal to 0, it will not be prime. So we have to return false in that case, right? Else we have to return true, or we can just directly write here return true. This is fine. So we are done with this method. We are done with this method. So just give me a second. Did I do anything wrong here? No need of brackets here. This is fine. So we are done with this one. Next thing is, we have to count how many distinct prime factors of a number using the linked list of primes, right? So what we are doing here, this step, this is the last step, logical part, right? So here we are counting, or we have to count the distinct prime factors of a number using the linked list of primes. So let's go with the another method, count distinct prime factors. Means here, prime factors means this one. Distinct prime factors of a number means, first we calculated all the primes, then we calculated the distinct prime factors. If you remember, in our case for n equals 10, the distinct prime factors were basically 6 and 10, which consisted of two prime numbers. One was 6, 2 into 3. It consisted of two distinct prime numbers, right? Another one was this one, what do you call, 10. It consisted of 2 into 5, right? 6, 4 and 8 also we can consider, but it miserably failed because it consisted of only one distinct, this one, what do we call, prime factor, right? So here in this case, what we'll do, we will count the distinct prime factors of a number using the linked list of primes. So I'll just go with static boolean here. So this will be count distinct prime factors, right? Count distinct prime factors. So this would be int x. This would be linked list of primes. So this is fine. So within this method, what we'll do, let's initialize the count to 0. Let's initialize the count to 0. So let me go with node temp equals primes dot head. So this is fine. So while this one temp not equal to null, then what shall we do? Well, temp not equal to null, then what shall we do? Uh, if it we'll check if the divisible by if it is divisible by current prime or not. If it is divisible by current prime or not. So I can write the simple if condition here x modulo temp dot value equals 0. Then we have to increment the count as well as we have to remove all the powers of prime. Means I'll just write the simple while loop here. This one will be x modulo temp dot value equals 0. This will be x equals x divided by temp dot value. X equals x divided by temp dot value. We are just removing all the powers of prime here. Next, let me come out of this one while loop. So here this next we have to move to the next value, right? So let me assign the temp to temp dot next, and finally we have to return the count. We have to return the count. 6 and 10 we got. So we have return the count of the this one distinct prime factors, the value that consisted of distinct prime factors. In our case it was 6 and 10, so we return the value 2, right? So we need to return the count here in this case, right? So we are done with the method can distinct prime factors. So the next step is let's go with the main function. Let's go with the main function, or yeah, main function. So here in this case, we are done with the code. Let's come to the main function here. So let me give here throws input output exception. This is fine. Next, within this one, as I've said, we'll be going with the fast input and fast output. So here, let's go with the fast input first. So I'll be making use of the buffered reader br equals. This one will be new buffered reader new. This would be input stream reader of system.n. This is for the fast input. So let's go with the fast output. This will be print writer pw equals new print writer of system.out. So this is fine. We are done with the input and output part. We are just going with the fast input and fast output. So not input and output. We are just so we have to move on with the further steps basically. Sorry. So we have to read the input number n. So we have to read the input number n, right? So we were given n equals 10 and n equals another value. All the inputs. We have to read the input number n. For that one, I'll just go with int n equals integer dot. So this one will be parseInt of br dot read line. Br dot read line. So this is fine. Br dot read line. So this is fine. The next step is we have to initialize the linked list for the primes. We have to initialize the linked list for the primes, right? So this is completely based on the linked list. So this would be linked list primes equals new linked list. So this is fine. We are making use of the custom linked list. So here in this case, we are initializing the linked list for the primes. So the next step is we have to find all the primes up to n. For that one, let me go with the simple for loop here. Int I equals to I less than or equal to n I plus plus. So within this for loop, we have already written this one is prime method. So let's make use of that one is prime of I then If it is, then we will make use of the add operation, and let's pass the I. Right, so this is fine. We are just finding all the primes up to n here. We have already written is prime method, so we don't have to worry about it. So we are done with this part. Then let's move on with the further things. So let me, we have to return the result, right? So let me go with this one, result. So I'll just go with the result equals 0. Let me initialize the result to 0 here. So here in this case, again, one more time, let's make use of the for loop here. Int, so this one I equals 1, I less than or equal to n, so I plus plus. So this is fine. Within the for loop, what we'll do, we have to check if exactly two primes exist or not, right? So we have to check if exactly two primes exist or not. Here in this case, we have written count distinct prime factors function already, right, method already. So I'll just go with a count distinct prime factors here. Let's pass the parameters I comma primes. So this is fine. So next, if this is equal to 2, means if we have exactly two primes, then we have to increment the result. So I'll just go with result plus plus. So this is fine. So here this would be, we have to print the result and flush the output. We are done with the logical part, except that we have to print the result and finally we have to flush the output. This is related to the input output. So let's print the this one result first. So this will be pw nothing but the print writer dot println. So we have to print the output, right? So here in this case, let me pass the result. After printing the result, we have to flush the output. So here in this case, pw dot flush. So yeah, we are done with the code. We are done with the code. This is it for the code actually. This is it for the code. I hope this works. Let's see. Just give me a second here. Here, let me pass the this one. Let me paste the this one. What do we call signature starter template here. So let's concentrate on the code rather than that. So yeah, let's check whether the code works properly or not. Means let's check with the different inputs, right? So I'll just copy this one. Let me paste it over here. Let me run the code. So here we are getting this one. What is wrong here? Class input output exception. Cannot find the symbol. What is wrong here? Line number 76. Let me come to the line number 76. Yeah, public static void main arguments throws input output exception. This is correct itself, right? So what's wrong here? So let's go with the exception. No need of input output exception here. This is fine. Yeah. Let me run this one now. Yeah. Here again. What is wrong? Public static void main string. We have this one. Of arguments. This is fine. Throws exception. This is also fine, right? So I cannot find symbol. Let's go with the line number 73 first. So here we have, oh, exception spelling. I have misspelled this one. So let me run this one again. So we have two errors now. Line number 73 error, incompatible times. Int cannot be converted. Return count. So what is wrong here? So we have initialized the count to 0, right? So we have went with int text linked list here primes. This is fine. Int we have initialized the count to 0. Temp to primes dot head. This is fine. Not equal to, this is fine. Temp equals temp dot next. This is fine. And we are just returning the count. What is wrong here? Then incompatible types. Int cannot be converted to boolean. So we are not converting to boolean here, man. So just give me a second here. So this is fine. Let's solve this one later. This one, let's come to the line number 991 here. Let's come to the line number 91 here. So what we have here, incomparable types boolean and int. If count distinct prime factors I comma prime equals 2. So what is wrong here again? So we are converting right here. In if count distinct prime factors, this method is fine. I comma primes. So this one equals to, then we are incrementing the result. What is wrong here then? So let's check what is wrong. So what this is saying here in the this one, what do we call line number 73, int cannot be converted to return count. This is saying, right? So here we have given boolean instead of the int here. It has to be static int, not the this one boolean. So let me run this one. Now we are getting the output too. We are getting the correct output, right? So let's try with the different input or the one more input that they have given here. The output that we need to get here is 8, right? So let me paste this one and let me run this one. So here we are getting the output 8. So our code works absolutely correct. So that was wrong. Basically the return type, here we wrote boolean and we are returning count which is of the type int. This doesn't work, right? So this doesn't match at all. So that is the reason we were getting error. Basically we have to give int here instead of the boolean, right? So there were some typos as well, right? So we corrected everything. Now we are getting the correct output for the desired output for the input, right? Accordingly with the code. So let me copy this one entirely and let me come here. Let me paste it over here. We have to select A itself, right? So this is option A. Yeah, this is fine. Now let me hit the submit button. I hope this works for all the test cases. Let's see. So let's wait for some time. So we would have solved this one even easier. So we went with the custom linked list, right? So that part was little bit lengthier. That part was little bit lengthier, right? So here you can clearly see all the test cases got passed, means the code got accepted here, right? So all the test cases got passed here. So whatever the code that we wrote works absolutely correct in this case, right? So I hope the solution part is completely clear along with the approach and the complexities, right? For now this is it. Thanks for watching, guys.